Today we are going to do section 5.6 on page 594. Now this is just some quick formulas for physics, so I'm just going to go over it, and I ask you to do all the examples as your homework, and then when it's done, then we're done with this section. Okay, there is not much worth mentioning from a mathematical point of view. So let's look at this. What are we talking about? First, the mass of the lamina. What's a lamina? Some shape, sheet, two-dimensional sheet, and that has an area. So the mass is equal to, you integrate over the area some function called rho, where rho is its density. And that's it. So please do example 5.55. Next, the moment. What's the moment? The moment is like the mass, except you stick a distance in it, y or x. Okay, and so you put it in and you integrate. So please do example 5.56. And next, we have something called the center of mass. The center of mass has an x coordinate and a y coordinate, and they're calculated by the moment divided by the mass. Okay, as you notice, here's a moment up there and the mass on the denominator. So having said that, please do example 5.57. Next, if something has a constant density, then the center of mass is the same as something called centroid. And so the centroid is defined as the moment divided by the mass when the density is constant. That is, the function rho up here on the other side is constant. So that is called the centroid, and please do example 5.8 and 5.9. Now next, we'll look at the moment of inertia. That is, the moment of inertia is when you put in y squared and do the integration instead of just y. You might wonder, what is the moment in inertia? The answer is we don't know and we don't care. Okay, it's just something you need to calculate. This is not a physics class. So let's keep going. So the moment of inertia is you stick the square of the distance in it. And for x, you square y squared, and for the iy, you stick an x squared. And then I0 is when you add ix and iy. Is that 0 or O? Who gives a rip? So for that, please do example 5.60. And then eventually, you have radius of gyration. The radius gyration is defined as the moment inertia up here divided by the mass. And then you take the square root. And then you have Rx, Ry, and R0, which is depending on Ix, Iy, and I0. So with that, please do example 5.61. And then those are just the dimensions in 2D. In 3D, the formulas are very similar, except now you have to integrate over 3 variables, but otherwise everything is exactly the same or almost the same. So for that, please do the last 3 examples in the section, 5.62, 63, and 64. And once you're done, we will not do any homework, but move on to the next section.